Last year, Nvidia returned 26%. This strategy returned 411% with no leverage, just 99 trades, and fully systematic execution. It's a trend following momentum strategy built on directional confirmation, volume acceleration, and strict entry conditions. Every trade is triggered by multiple aligned indicators, no discretionary overrides. Here's how entries work. For long positions, the average directional index, or ADX, must be greater than 25, confirming that the market is trending with sufficient strength. Then the positive directional indicator must be greater than the negative directional indicator, indicating that the bullish movement is dominant. Only when both conditions are true and the system is not already long, a long position is entered. For short positions, the percentage volume oscillator, or PVO, must be positive, confirming that volume momentum is rising. The fast EMA, exponential moving average, must be below the slow EMA, and a bearish crossover must have just occurred, ensuring signal freshness. When all three conditions are satisfied and no short is active, the system opens a short. Entries are based on strict conditional logic, not prediction. If one element fails, the trade is skipped. So let's break it down step by step in the code. We're going to begin by importing the libraries we're going to be using for this video. So we're going to be using Pandas, we're going to be using the Backtesting.py library, and we're going to be using the technical analysis library. So let's run that. And next we're going to be loading in our data we're using for this video. So this is 15-minute interval data for Nvidia over the last 12 months. That will be available in my GitHub linked below. So we can see we've got a snapshot of our data here. Now, the next thing we're going to do is we're going to add the technical indicators. So all of the technical indicators from the technical analysis library. So we're just going to run that now. Now we can see we've got our new output with all of the technical indicators that we've just added. So we have now 92 columns. Now, we're not going to be using all of these, but it's just easier to add them all. And then obviously we can pick and choose which ones we're going to use. So the next thing we're going to do is we're actually going to split our data into training and testing. Now, it's technically not training, but I've just split it that way just for simplicity. So our training data is the first 6 months of the 12 months of data we've downloaded or loaded in, and the testing data is the latter 6 months, the most recent 6 months. Let's run that and split our data. Next, we're going to create the strategy itself. So I'm going to create a new class, and I'm going to call this strat. And this is going to inherit from the strategy class that we imported from the Backtesting.py library. Now, we want a class variable. So we want to have a variable called current position direction. Now, this is going to track the current trade direction, whether it's long, short, or none. Now, for every single strategy class, we need to have this initialization function, this constructor. Now, we're not going to put anything in here, so we're just going to leave it blank for now. Then we have the next function. So this is run for every single candle within the data. So we're going to start with our long entry. We want to enter long when the ADX is greater than 25, so that confirms sufficient trend strength. And the positive directional indicator, so this one here, we want this to be greater than the negative directional indicator, so this is a bullish directional bias. Now, if we're not already long, we want to close any open position, so this might be a short position, and we want to open a long position and then set our current position direction to long. And next we have our long exit. So the long exits, when the price crosses below the PSAR, this is a trailing stop triggered, and then the Vortex indicator crosses bearish, so this confirms the shift in directional momentum. So at this point here, we want to close our long position. So obviously we want to check that if the long position is open, then we want to close that and then reset this to none. Next, we have the short entry. So the short entry, we want the PVO to be greater than 0. So this confirms that volume momentum is present. We want the fast EMA to be less than the slow EMA. So this is the bearish structure. And then we want the bearish EMA crossover to have just occurred. So this confirms a fresh signal. And then if not already short, we want to open the short position and then set this current position direction to short. And then finally, we have our short exit. So the short exit, if the CCI is less than 0, this signals loss of downside momentum. And then if the stochastic RSI is less than 0.5, this confirms momentum weakness or an oversold condition. And then we want to close the short position on the confirmed weakening trend. So that is everything for this strategy in code. Now I'm going to run that to lock that in, and then I'm going to insert a cell below, and we're going to run the backtest to begin with on the training data. So I'm going to load up this backtest with the training data, the strategy, 1 million in cash, I've set the commission to be 0.2%, exclusive orders to be true and hedging to be false. And I'm going to run this and we can see what performance is like. So over the first 6 months of the 12 months of data we downloaded, we have a 127% return. And this beats buy and hold massively, which is 47% return. Now, notice our win rate's quite low, but then our average trade percentage is 1.729% or 1.73%. And this is very relevant because you can have a low win rate, but if your average trade is very good, then it doesn't matter so much. So we've got pretty good performance, well, very good performance on the training data the first 6 months. Now let's test this out on the testing data, right? Because we could have overfit. We could have a strategy that performs well on the first 6 months of that data, but what if it doesn't perform well on unseen data? So let's run that on the testing data, and let's have a look at the performance. So we have 129% return. The buy and hold return is minus 14%, so 14% down. So it's massively better than buy and hold. And then we see a somewhat consistent win rate. So it is better on the test sets, but it's still not great, right? 56.8% isn't perfect, isn't amazing. And just to kind of conclude things here, what I'm going to do is I'm going to run this on the entire data just to give us a full picture of the performance over the course of 12 months. And that is where we get the 411%, 412% return. Now, when you compare that to the buy and hold return of 26%, it's very good. Now, this doesn't mean that this strategy is definitely going to work over the next 6 months, the next year. The market conditions for Nvidia over the last 12 months may not occur over the next 12 months, right? So that's very important to consider. But overall, this strategy is a good starting point and it could definitely be optimized further. So if you enjoyed this video, please give it a like, subscribe, and I will see you in the next one.